Yeah. Thank you, Paul.
You're welcome.
Okay. Well, thank you, everybody, and welcome to this Friday, October 5th, 2018's Azure Power Lunch. My name is John Ringhofer, and as you can see, I'm a technical solutions professional in the data platform area of Microsoft. That means I support our solution sales professionals in data and AI for the South Central region. And so today's topic is toward a more secure, trustworthy Internet of Things. So let's dive right into it. So the Internet of Things does, as you may have presumed, that it poses a unique security, privacy, and compliance challenges to businesses worldwide, right? And we are already delivering results in IoT, but we always have to consider that, unlike traditional cyber technology where these issues revolve around software and how it's implemented, IoT concerns what happens when the cyber and the physical worlds converge, right? So protecting IoT solutions require ensuring the secure provisioning of devices, secure connectivity between these devices and the cloud, and secure data protection in the cloud during processing and storage. Now, working against these types of functionalities, however, are these resource-constrained devices or geographic distribution of deployments and a large number of devices within a solution. So one thing we'll explore is how something we call IoT solution accelerators provide a secure and private Internet of Things cloud solution. Now, these solution accelerators, basically they deliver a complete end-to-end solution with security built into every stage from the ground up. Now, Microsoft developing secure software is part of the software engineering practices, best practices, and it's rooted in Microsoft's decades-long experience of developing secure software. Now, to ensure that, the Security Development Lifecycle, also as called SDL, Security Development Lifecycle is the foundational development methodology, and we couple that with a host of infrastructure level security services such as Operational Security Assurance, or OSA. So again, we couple SDL with Operational Security Assurance and the Microsoft Digital Crimes Unit, Microsoft Security Response Center, and Microsoft Malware Protection Center. So the solution accelerators offer unique features that make provisioning, connecting to, and storing data from IoT devices easy and transparent, and most of all, secure. So we'll examine Azure IoT Solution Accelerators, security features, and deployment strategies to ensure security, privacy, and compliance challenges are addressed, and like it says here, Microsoft's leading the way in that. Now, basically, why do we have leadership? Just a quick, mention here, a call out is that we offer end-to-end IoT infrastructure security best practices, as I mentioned, hardware-based security design patterns and partnerships. There's 7 principles there that we'll touch on in the later slide. Design, development, and deployment operations of secure IoT infrastructure, which is our security program, and then some standards and regulations, which, if we have time at the end, we'll cover. Now, you may ask, what could happen if we don't make the right choice of the right IoT software and the service provider that has extensive experience running services spanning across many verticals and geographies, but also able to scale in a secure and transparent fashion? Well, perhaps something like this on a personal level, right? But even in businesses, right? We at Microsoft often talk about the intelligent cloud and the intelligent edge that helps deliver digital transformation, but security is what engenders reliability and confidence that you won't be hacked, and you will be able to, use and rely on trusted connected devices and services. Now, the focus of this Azure Power Lunch talk is IoT security, but it wouldn't be fair to jump into this topic without at least a brief review of what Microsoft Azure IoT technologies are. Here we see a depiction of the Azure IoT product portfolio and its available PaaS, SaaS technologies and solutions. And it presents the 2 paths that are available for building your own solution. One is platform as a service, right? PaaS. You build your app using Azure IoT Solution Accelerators, which are a collection of enterprise-grade pre-configured solutions that enable you to accelerate the development of custom IoT solutions. So you can think of them as templates. And the second area is software as a service, right? SaaS. Get started really fast with the SaaS via Azure IoT Central. And that's our new SaaS solution to develop IoT apps without being exposed to the complexity of IoT solution and solution building. So if your organization lacks the resources to build your own IoT solution, then Azure IoT Central is a codeless IoT solution that can create device models, dashboards, and rules in minutes. We'll be focusing mostly on the top left-hand side of this diagram, the PaaS solutions, and how IoT security plays in a few key areas like Azure IoT Hub, Azure IoT Edge, and Azure Sphere. And here we'll quickly review the fact that IoT solutions require secure bidirectional communication between devices. That's obviously possibly numbering in the hundreds of thousands or even millions, right, of devices, and a solution backend. So for example, a solution might use automated predictive analytics to uncover insights from your device to cloud event stream. This diagram shows the key elements of a typical IoT solution architecture. So the diagram is agnostic on the specific implementation details, such as the Azure services used and device operating systems. In this architecture, IoT devices collect data that they send to a cloud gateway. The cloud gateway makes the data available for processing by other back-end services, and these back-end services can deliver data to, other line of business applications and or human operators through a dashboard or other presentation device. Now, securing the Azure IoT deployment can be divided in basically these three security areas. First, on the left-hand side, device security, right? Securing the IoT device while it is deployed in the wild. Now, the IoT solution accelerators secure IoT devices by basically two methods. They provide a unique identity key or security tokens for each device, which can be used by the device to communicate with the IoT hub. And second, it uses an on-device X509 certificate and private key as a means to authenticate the device to the IoT hub. So this authentication method ensures that the private key on the device is not known outside the device at any time, and that provides a higher level of security. And then the IoT hub uses security tokens to authenticate those devices and services to avoid sending keys on the network. And additionally, which is also key, pardon the pun, but additionally the security tokens are limited in time and validity and scope. So the Azure IoT SDKs automatically generate tokens without requiring any special configuration. So some scenarios, however, do require the user to generate and use security tokens directly. And those scenarios include the direct use of, transport technologies like MQTT, AMQP, or HTTP services, or the implementation of the token service pattern. The second area, as you see in the middle, is connection security, right? Ensuring all data transmitted between the IoT device and IoT hub is confidential and tamper-proof. So internet connection between the IoT device and IoT hub is secured using transport layer security, right? TLS, the TLS standard. Now, Azure IoT supports TLS 1.2, but it also supports TLS 1.1 and 1.0 in that order. So support for TLS 1.0 is provided for backward compatibility only. If possible, use TLS 1.2 as it provides the most security. And finally, on the right-hand side, you have cloud security, right? Providing the means to secure data while it moves through and is stored in the cloud. So Azure IoT Hub allows definition of access control policies for each security key. And it uses a set of permissions to grant access to each of the IoT Hub's endpoints. So those permissions limit the access to an IoT hub based on functionality, right? Some of those functionalities are like registry read or registry read write, which grants read or read and write access to the identity registry, or things like Service Connect, which grants cloud service-facing communication and monitoring endpoints, and then you have Device Connect permissions, which grants access to device-facing endpoints. So, for example, it grants permission to send device-to-cloud messages and receive cloud-to-device messages. So that's permission used by the devices. So, what happens if, you can't, if we address what could happen if you don't address security and IoT in a unified, holistic manner? Well, a lot of bad things, but for starters, this is just one humorous example, right? Nobody wants to deal with piece parts. So think of Microsoft solution accelerators as enabling the delivery of what I mentioned earlier, true simplicity and transparency in a completely secure environment to deliver on making the IoT experience as pleasant, easy, and useful as possible. So what is the case for the end-to-end security in IoT? Well, again, end-to-end IoT security might mean different things to different people, but there are commonalities. On a personal level, it might look like this, right? But However, end-to-end IoT security in business usually has a more comprehensive meaning, where the repercussions of not addressing it in that end-to-end manner can have serious consequences. So to mitigate those consequences, you have to understand the foundational piece parts and their technical underpinnings. So let's take a look at some of these challenges. So this is just an example, right, of off-the-shelf hardware. You can see the questions there about whether the OS or the silicon is secure. Can you perform device management, and can the device be tampered? So the basic underlying premise is if you can answer no to any of those questions, you have security risk to mitigate. So there is a clear opportunity for, folks like system integrators with practices around IoT and data analytics to develop IoT solutions customized, obviously, to their end customers. So this opportunity could come from their specific customers with unique or complex data analytics requirements, maybe with brownfield environments with devices from many different vendors from different years, sending data in a variety of formats and protocols, or with complex IT environments. You may have a variety of line of business applications to connect to, unique data security and governance requirements, and maybe they're without the capabilities or desire to develop the solution themselves. So in order to develop that custom IoT solutions for their customers, these system integrators could, first build the customer solution on top of an IoT platform, two, build the customer solution on top of a cloud platform, and or three, provide ongoing data analytics services such as creating new reports, retraining machine learning models to keep them fresh, etc. So the IoT space can be very complex, fragmented, and a crowded ecosystem. So as such, it's hard for software developers to identify where exactly the opportunity is. However, there are still many opportunities for both ISVs and system integrators in IoT. The first opportunity is to ease the pain of connecting machines to an edge device or a cloud gateway. The second is creating value from IoT data by extracting actionable insights. And of course, these actions can greatly improve business to be more competitive. But there's also an opportunity for ISVs in the development of these IoT platforms and pre-built IoT apps to accelerate the development of these IoT solutions. For system integrators, the opportunity is the development of custom IoT solutions. For either case, both the ISVs and the SIs must have strong IoT data analytics, data science, and cloud skills, in addition to deep expertise in the industry or industries that they're deploying IoT in, such as manufacturing. Now, in order to address the various skills required to think about IoT security, we need to think about the various roles involved. And though they might be in different organizations or in the same organization, right? So these could also be the same person, but the roles are about what each does. And usually there's a coordination of these roles, which ensures, for example, the solution developer needs to understand what the hardware manufacturer is designing and what software can and should run on the hardware, is it updatable, etc. So what are some of the security best practices for each role? Well, this lists obviously some of the roles here and what they do. Some best practices, for example, the IoT hardware manufacturer or integrator is scope the hardware to minimum requirements. That's for the features required for operation of the hardware. Maybe like using USB ports only if necessary for the operation of the device, make it hardware tamper-proof, build around the secure hardware like encrypted storage or boot functionality, making upgrades secure like the firmware updates, taking the lifetime of the device into account. The solution developer best practices are things like following secure software development methodologies, basically from the ground up, right? From the inception of the project all the way to implementation, testing, and deployment. So they have the choices of platforms, languages, tools, influenced by those methodologies. And we have a whole Microsoft, like I said, security development lifecycle that provides a step-by-step approach for that. They might choose open source software. They need to, if they're using open source, provide that with care, right? Because the activity level of the community of each of the open source components come into play. And of course, the integration with care, right? Make sure, they have to be aware that security flaws can and do exist at the boundary of libraries and APIs. For the solution developer, they want to deploy the hardware securely, keep authentication keys safe, So those are pretty obvious, taking obviously in the cloud into account, keeping the keys physically safe even after a deployment, and watching out for compromised keys that could be used by a malicious device or masquerading as an existing device. And finally, the IoT solution operator. Some best practices are keeping the system up to date, of course, with the drivers and operating system updates on all the IoT devices. Even in Linux, right? Make sure that they're protected against malicious attacks, protect against malicious activities, and taking the appropriate steps to mitigate both internal and external threats, auditing frequently, physically protecting the overall IoT infrastructure, which is where some of the worst attacks happen, and of course detailed logging to see where those attacks are, and then protecting the cloud credentials. Now, security does start with a threat model, right? We've long used threat models for products. We've made our threat modeling process publicly available. Basically, there's a lot of unexpected benefits beyond the immediate understanding of what the threats are that are most concerning. For example, it also creates an avenue for a more open discussion with others outside the development team, which can lead to new ideas and improvements in the product and the overall solution, right? But the objective of the threat modeling is to understand how an attacker might be able to compromise the system, and then make sure appropriate mitigations are in place. So it forces the design team to consider those mitigations as the system's designed rather than after it's deployed. And that's critical, right? Because retrofitting security defenses to a myriad of devices in the field is infeasible, and it's error prone, and it leaves the customers, basically totally at risk. So first, when do you want a threat model? It offers the greatest value when you incorporate it, like I said, in the design phase. There you have the greatest flexibility to make changes to eliminate threats, and eliminating threats by design is the desired outcome. So it's much easier than adding those mitigations and then testing them and ensuring they remain current. And also, such elimination is not always possible. So it becomes harder to eliminate threats as the product becomes more mature, and that ultimately requires more work and a lot harder trade-offs than threat modeling early on in the development. Now, what to threat model? You should threat model the solution as a whole, and also focus in areas such as the security and privacy features, the features whose failures are security relevant, and the features that touch a trust boundary, which we'll talk about in a minute. And who threat models? Well, basically it's a process like any other, so it's a good idea to treat the threat model document like any other component of the solution, and you validate it. Many development teams do an excellent job capturing the functional requirements for the system that benefit their customers, but identifying non-obvious ways, and I'll repeat that, identifying non-obvious ways that someone might misuse the system is a lot more challenging. So threat modeling can help development teams understand what an attacker might do and why. Now, I dedicated a separate slide to the how, right? We already touched on when, what, and who, but the threat modeling processes of how to do the threat model is basically 4 steps. And they are: model the application, enumerate the threats, mitigate the threats, and then validate the mitigations. So basically the process, there's 3 rules of thumb to keep in mind when building that threat model. One is to create a diagram, such as this one, out of the reference architecture. Then secondly, start breadth first, right, across the board. Get an overview and an understanding of the system as a whole before you deep dive. And that approach helps ensure that you deep dive in the right places. And then the third process step is you actually drive the process. Don't let the process drive you, so to speak, right? Because if you find an issue in the modeling phase and you want to explore it, you actually go for it, right? Don't feel that you need to follow these steps slavishly. Now, the threats, there's 4 core elements of a threat model, and they are the processes, the data stores, the data flow, and the external entities, right? Processes such as web services, Win32 services, NIX daemons. There's some complex entities, for example, field gateways and sensors, that can be abstracted as a process when a technical drill down in those areas are not possible. The second, right, the threat core element is data stores. Anywhere data is stored, such as a configuration file or a database, like Cosmos DB, for example, very good for IoT. Data flow, where data moves between other elements in the application, is the third core element of a threat. And the fourth core threat element is external entities. So anything that interacts with the system but's not under the direct control of the application. So examples obviously include users and satellite feeds. So basically all those elements in the architectural diagram are subject to various threats. And Microsoft uses the STRIDE mnemonic. And basically we have documentation, I believe a white paper on threat modeling in STRIDE to know more about the STRIDE elements. But for those who may not have heard of STRIDE, the security development lifecycle uses the STRIDE approach, where STRIDE is an acronym that encompasses the idea that software comes under a predictable set of threats. And these categories of threats are spoofing, tampering, repudiation, info disclosure, denial of service, and elevation of privilege. So you can see how that spells out STRIDE, right? But different elements of the application diagram are subject to certain STRIDE threats. So for example, processes are subject to STRIDE, all 6 of those threats. Data flows are subject to TID. Data stores are subject to TID as well, right? Like tampering, info disclosure, and denial of service. And sometimes data stores are also subject to R, which is repudiation, like where data stores are the log files. And then external entities like are subject to SRD. So that's the spoofing, the repudiation, and the denial of service. Now finally, we recommend a typical IoT architecture should be divided into several component or zones as part of a threat modeling exercise. And those zones include device, field gateway, cloud gateways, and services. So zones, and you can see some of them here, are a broad way to segment a solution. So each zone often has its own data and authentication and authorization requirements. But these zones can also be used to isolate damage and restrict the impact of low trust zones on higher trust zones. So each zone is separated by a trust boundary, and that's noted as the dotted red line right here. So it represents a transition of data and info from one source to another, and during that transition, data could be subject to any of the STRIDE elements. Now, hardware-based secure design. Basically, in the interest of time, we'll just accelerate it here, but these are the different areas: physical access, compute hardware, software development software, non-standard security procedures, and availability of attack skills and tools. So you can see the different threat landscape. I won't belabor this slide. But moving on, there's these 7 properties of highly secure devices, right? And real quickly, you can see, I'm not going to read the questions at the bottom, you can see those, but the hardware-based root of trust, right? Those are unforgeable cryptographic keys that are generated and protected by the hardware. Small trusted computing base, private keys stored in a hardware-protected vault that's inaccessible to the software. Defense in depth, multiple mitigations are applied against each threat, and countermeasures mitigate the consequences of a successful attack on any one vector. Compartmentalization, right? Hardware enforced barriers between the software components, prevent a breach in one from propagating to the other areas. And certificate-based authentication, signed certificate, it's proven by unforgeable cryptographic keys, it proves the device identity and authenticity. And renewable security, that renewal brings the device forward to a secure state and revoke compromised assets. It revokes those compromised assets for known vulnerabilities or security breaches. And online failure reporting, right? A software failure, such as a buffer overrun induced by an attacker probing security, is reported to the cloud-based failure analysis system.
Hey,
yes?
Paul, there's a question in the IM window.
Okay, question?
We had announced Azure Sphere last week, so do you think that those threat models, they're already included with Azure Sphere?
I believe they are. I'd have to double check on that, but yeah, I believe they are.
Okay.
Yep, good question. Now, the hardware security module, and we're about to touch on Sphere too. The hardware security module is used for the secure hardware-based storage of device secrets, right? It's the most secure form of secret storage. The Azure IoT team has worked with the standards organizations and industry partners to employ the latest in security best practices to deploy for support for a wide variety of HSMs. They offer that resistant and resilient hardware root of trust in the IoT devices. So the Azure IoT platform transparently integrates HSM support with platform services like the Azure IoT Hub Device Provisioning and Azure IoT Hub Device Management. And that enables customers and developers to focus more on identifying specific risks associated with their apps and less on security deployment tactics. So in summary, those HSMs offer a major defense layer to raise trust in authentication, integrity, confidentiality, privacy, and more. The Azure IoT team is working directly with major HSM manufacturers to enable access to a wide variety of those HSMs. So the bottom line is that rather than coerce the use of one HSM for security hardening, Azure IoT Edge takes a more customizing and accommodating approach. Now, with Azure Sphere, we're taking the Microsoft into a swim lane that we've never really been in before, and that's the world of these microcontrollers, right? And for those who might not be familiar, a microcontroller is literally a single chip computer that has a processor, memory, storage, and I/O capabilities for a very low price point. So every year, more than 9 billion microcontroller units, or MCUs devices, are shipped worldwide into a deployed population of somewhere between 50 and 100 billion devices globally. So think about that. MCUs go into everything from smart devices in the home and workplace to industrial equipment. So today, fewer than 1% of MCUs are connected. That's really something to ponder, right? Because as device manufacturers connect their MCU-powered devices to the internet, they open up great opportunities for new device types, business models, and revenue streams. But they also open up to a whole new world of risks, where because packets not only go out, but packets can come in as well, attacks and breaches can drive away consumers and permanently damage brands. So basically, this is just a quick organizational view of like how Microsoft Sphere works, right? The Azure Sphere MCU includes built-in hardware-based security. The purpose-built Azure Sphere OS adds a 4-layer defense and an in-depth software environment. And it combines security innovations that are actually pioneered in Windows, like a security monitor, a custom Linux kernel to create highly secured software environment, and a trustworthy platform for those new IoT experiences. And then we also offer the Azure Sphere Security Service, which renews security to protect against new and emerging threats. So here is just a quick fictional company called Contoso. View it as a dishwasher manufacturer who embeds the Azure Sphere MCU into its dishwashers. So the DW100 dishwasher couples the MCU with several sensors and onboard application that runs on the Azure Sphere MCU. So the onboard application communicates with the Azure Sphere Security Service and with the Contoso Cloud Service like Azure. So starting from the top left and moving clockwise, right, Microsoft releases updates for the Azure Sphere device software through the Azure Sphere Security Service. Then the Contoso product engineering releases updates to its DW100 app through the Azure Sphere Security Service. Then that service securely deploys the updated device software and the Contoso DW100 app software to the dishwasher at the end user locations. Then the Contoso dishwasher support communicates with the Azure Sphere Security Service to determine which version of the Azure Sphere software and the app software should be running on each end user device, and they glean any error reporting data that has been reported to the service, and they obtain, any additional info. Then the Contoso Cloud Service, such as Azure, supports the app for troubleshooting, data analysis, and customer interaction. And then finally, the Contoso DW100 models at the end user locations download updated software over their connection to the Azure Sphere Security Service. So a pretty comprehensive view there. Now, we're trying to answer questions like what secure hardware to use, how do I gauge the level of security, how much security do I really need, and how much premium should I place on secured hardware. Basically, we've published a new white paper to shed light on that, and so we can just share that link, but you see the link there and we can share that out later. We have a whole deployment on the planning, architecture decision, and execution phases, which you can see are broke down into sub-phases. And of course, I imagine the linkage between this and the previous slide would be something like our IoT architectures and this new threat model that comes with IoT is driving innovations in security as well, right? And though that architecture can have a major constraint impacting security. So a new approach is needed to manage that new IoT landscape, because the solutions built in the hardware is the way to go Some of the major considerations are it's cheap or it's free. Second, it's easy and will fold right into the existing infrastructure. And third, that it's standard-based. And so those points are critical because DICE, which is a new standard, built-in hardware identity, can build out lots of interesting and important security considerations with it. Finally, the device provisioning service is a helper service for IoT Hub, and that works to automate the provisioning process. So I know we're a little over time here, and my apologies, but basically this is the last slide. We want to automate full provisioning, right? DPS offers dynamic, just-in-time binding of a device to a specific IoT hub within a multi-hub solution. So binding can be based on load balancing, geolocality, or tied to a specific hub. DPS is also the easiest way to mass provision devices by providing concierge-like functionality for devices, which are just coming online. Now, we know that IoT devices have a long lifetime and that they need URL stability, which we offer via a single global device provisioning endpoint. Now, you register devices via DPS is also more secure than with the IoT Hub alone because of the secure device identity validation is done. That validation is done by DPS. So we've also made improvements to the SDK to make using hardware-based secure key storage a no-brainer. So all in all, DPS means less time required to deploy the solution because provisioning is done automatically. And if that wasn't enough, DPS works across regions and across subscriptions to support multi-tenant solutions. So that's basically it. Any questions?
I don't see any question in the IM window. I think there was one question, John, that I...
Okay.
Yeah.
Great. Okay, well, I appreciate your time, folks.
Thank you very much, John. Really
yeah, thanks, Naveed. Have a good day.
You too.
Bye-bye.